Right now we're going to take a look at a word problem from sections 5.1 or from 5.2 relating to exponents. So we have shoes cost $62 at a local store. If the cost of the shoes increased by 2.3% per year, we want to find out the price for the following three. So how much they'll cost in 5 years, how much they'll cost in 21 months, and how much they costed 15 months ago. So all of these represent exponential growth. So we're going to use the same formula for all three. All three would be our growth formula, which is y equals a times 1 plus r to the tth power. It's not going to change throughout. A is always going to be our initial value, which in this case is 62. Our rate is 2.3%, but we don't put that in as a percent here. We put that in as a decimal. So to move changes to a decimal, we would move our decimal place 2 points to the left. So we would have the decimal 0.023. All of that being raised to the t. In this case, that would be 5. So I'm going to go through and actually input into my calculator. I'm sorry, that should be. I'm going to actually input this into my calculator. So let's actually go ahead and do that right here. Now I'm going to plug all this in. I'll do 1.023 raised to the 5th power. Alright, and then multiply that by 62, which gives me 69.4656. So what we're going to do is we're going to end up rounding this to 2 decimal places. So if I round that to 2 decimal places, we would end up with 69.47. So that means the cost in 5 years would be $69.47. So now we're going to go through the same thing in 21 months. Most of this is going to be exactly the same. We're still talking about exponential growth here. All of this is going to be the same. 62, 1 plus r is exactly the same. Now our t value is going to change. Now we're talking about 21 months. So we got to think about how many years that is going to be, because our t value right now is in terms of years. So 21 months, I know that's 1 full year and then 9 months left over. So in terms of a year, if I think about, that would be 1 9/12 of a year, because 9 months of the 12. If I simplify that, I would have 1 3/4. And in terms of a decimal, I would write that as 1.75. So my number here would be 1.75. That's how many years 21 months would be, 1.75. Now, just like before, I would go through and do the same thing in my calculator. I would plug in 1.023 raised to the 1.75, because that's how many years the 21 months would be, which gives us our answer, and we multiply that by 62. So what it tells us, we would have $64.52, 64.52. That would be our cost in 21 months. That would be our cost 5 years. Now, last but not least, 15 months ago. Don't confuse this because we're talking about 15 months ago. This is still an exponential growth question. So our formula is going to stay the same as it has all along up to this point. 62 is our initial value. Our growth rate is still this. The months ago is going to mean a negative exponent. That's all it's going to be. We're going to look at it in terms of a negative exponent. So we know this is going to be negative. Now 15 months ago, same sort of process we had done in part B. We're going to go through and figure out how many years that actually is. We know 15 months. If we divide that by 12, you would get 1.25. That's one way of doing it. Or you kind of think about it and say, alright, well I know I'm going to have 1 full year and 3 months left over. What that gives me, 1/3/12, which we end up just simplifying to that 1.25. Again, it would be 15 months is 1.25 years. So with all that being said, we know it's going to be negative here because we're talking about 15 months ago. So we would say negative 1.25. And just like the other questions, we would plug all of this in to our handy dandy calculators. So we'll say 1.023 raised to the negative 1.25. Alright, and then we multiply that by 62. That tells us $60.26. $60.26. What that means is 15 months ago, that's how much the sneakers costed.